6425. The maximum indicated airspeed permitted when operating an aircraft within 4 nm of the primary airport in Class D airspace is A. 200 miles per hour, B. 200 knots, C. 250 knots. The correct answer is B. When operating an aircraft within 4 nm nautical miles of the primary airport in Class D airspace, there are specific speed restrictions that pilots need to adhere to for safety and traffic management purposes. The maximum indicated airspeed permitted in this scenario is 200 knots. This speed restriction is in place to ensure proper control, safe operations, and to maintain separation between aircraft operating in close proximity to the primary airport. Operating at a maximum indicated airspeed of 200 knots within 4 nm of the primary airport allows for predictable and manageable aircraft movements in the vicinity. It helps reduce the potential for conflicts and provides pilots with adequate time and maneuverability to maintain safe separation from other aircraft, particularly during critical phases of flight, such as takeoff and landing. It's important to note that this speed restriction applies specifically to Class D airspace and within 4 nm of the primary airport. Different airspace classes and proximity to other types of airports may have varying speed restrictions. Pilots should always consult the relevant aeronautical charts, NOTAMs, notices to airmen, and any specific instructions or air traffic control communications to determine the exact speed limitations for their particular situation. By adhering to the maximum indicated airspeed of 200 knots within 4 nm of the primary airport in Class D airspace, pilots contribute to maintaining safety and efficient traffic flow in the area. Therefore, in the given scenario, the maximum indicated airspeed permitted when operating an aircraft within 4 nm of the primary airport in Class D airspace is 200 knots. 6426. To operate an aircraft over any congested area, a pilot should maintain an altitude of at least A. 500 feet above the highest obstacle within a horizontal radius of 1,000 feet. B. 1,000 feet above the highest obstacle within a horizontal radius of 2,000 feet. C. 2,000 feet above the highest obstacle within a horizontal radius of 1,000 feet. The correct answer is B. When flying an aircraft over any congested area, there are specific altitude requirements that pilots must follow to ensure safety and minimize the risk of collisions with structures or obstacles on the ground. These requirements are in place to protect people and property on the ground, as well as to maintain a safe operating environment for the aircraft. According to aviation regulations, when operating over any congested area, a pilot should maintain an altitude of at least 1,000 feet above the highest obstacle within a horizontal radius of 2,000 feet. This means that the pilot must fly at an altitude that provides a minimum clearance of 1,000 feet above the tallest structure or obstacle within a 2,000-foot radius around the aircraft's current position. The purpose of this altitude requirement is to ensure that there is adequate vertical separation between the aircraft and any obstacles, buildings, or populated areas below. It helps prevent potential collisions, provides a margin of safety, and reduces the risk of damage to property or harm to people on the ground. It's important to note that the altitude requirement may vary in different regulatory jurisdictions or specific airspace designations. Pilots should always consult the relevant aviation regulations, aeronautical charts, and any specific instructions or restrictions applicable to the area they are operating in to determine the exact altitude requirements. By adhering to the minimum altitude of 1,000 feet above the highest obstacle within a horizontal radius of 2,000 feet, pilots contribute to the safe and responsible operation of aircraft over congested areas. Therefore, in the given scenario, to operate an aircraft over any congested area, a pilot should maintain an altitude of at least 1,000 feet above the highest obstacle within a horizontal radius of 2,000 feet. 6428. Except when necessary for takeoff or landing, what is the minimum safe altitude for a pilot to operate an aircraft anywhere? A. An altitude of 1,000 feet above the highest obstacle within a horizontal radius of 2. B. An altitude of 500 feet above the surface and no closer than 500 feet to any person, vessel, vehicle, or structure. C. An altitude allowing, if a power unit fails, an emergency landing without undue hazard to or property on the surface. The correct answer is C. When operating an aircraft, it is essential to maintain a safe altitude to ensure the safety of people and property both in the air and on the ground. The minimum safe altitude for operating an aircraft anywhere, except when necessary for takeoff or landing, is determined by the principle of allowing an emergency landing without posing undue hazards to persons or property on the surface. In practical terms, this means that the pilot should choose an altitude that provides sufficient clearance from the ground, obstacles, and populated areas to allow for a safe emergency landing in the event of a power unit failure or any other critical situation. The exact altitude required to meet this standard may vary depending on the specific circumstances and location of the flight. The pilot must use their judgment and consider factors such as terrain, weather conditions, available landing sites, and the performance characteristics of the aircraft to determine the appropriate minimum safe altitude. The goal is to select an altitude that provides a reasonable margin of safety and allows for a controlled descent and landing without endangering people or property on the surface. It's important to note that the minimum safe altitude requirement does not have a specific numerical value, as it depends on the unique conditions of each flight. However, the key principle is to maintain an altitude that allows for an emergency landing without posing undue hazards. Pilots should be familiar with and adhere to applicable aviation regulations, which provide guidelines and considerations for determining safe altitudes. Additionally, local regulations and airspace restrictions may impose specific minimum altitude requirements that pilots must comply with. By operating at an altitude that allows for an emergency landing without undue hazard to persons or property on the surface, pilots contribute to the overall safety of aviation operations. Therefore, in the given scenario, except when necessary for takeoff or landing, the minimum safe altitude for a pilot to operate an aircraft anywhere is an altitude that allows for an emergency landing without posing undue hazards to persons or property on the surface. 6427. The minimum distance at which an airplane may be operated over a structure which is located in a sparsely populated area is A. 500 feet above the ground. B. 500 feet from the structure. C. 1,000 feet from the structure. The correct answer is B. When flying an airplane over a structure located in a sparsely populated area, there are specific guidelines regarding the minimum distance that should be maintained to ensure safety and prevent potential hazards to both the aircraft and the structure. According to aviation regulations, the minimum distance at which an airplane may be operated over a structure in a sparsely populated area is 500 feet from the structure. This means that the airplane should maintain a horizontal distance of at least 500 feet away from the structure while flying. This distance requirement is in place to mitigate the risk of any potential accidents or collisions between the airplane and the structure. It allows for a margin of safety and provides clearance for the aircraft to maneuver safely without posing a hazard to the structure or its occupants. It's important to note that this distance requirement may vary based on specific regulations and local airspace restrictions. Pilots should always consult the applicable aviation regulations, aeronautical charts, and any specific instructions or restrictions applicable to the area they are operating in to determine the exact distance requirements. By adhering to the minimum distance of 500 feet from the structure in a sparsely populated area, pilots contribute to the safe and responsible operation of the aircraft, while also ensuring the integrity and safety of the structures below. Therefore, in the given scenario, the minimum distance at which an airplane may be operated over a structure located in a sparsely populated area is 500 feet from the structure. 6444. What type of the planned cruise altitude should be entered on a flight plan? A. True airspeed. B. Indicated airspeed. C. Estimated ground speed. The correct answer is A. When creating a flight plan, it is important to provide accurate and essential information about the planned flight, including the type of speed to be entered at the planned cruise altitude. The speed that should be entered on a flight plan at the planned cruise altitude is the true airspeed. True airspeed, TAS, refers to the actual speed at which the aircraft is moving through the air. It represents the speed relative to the surrounding air mass, unaffected by variations in atmospheric conditions. True airspeed is essential for flight planning as it directly affects fuel consumption, time en route, and navigational calculations. The true airspeed is determined by adjusting the indicated airspeed, IAS, for the non-standard atmospheric conditions at the planned altitude. Since air density decreases with increasing altitude, the true airspeed will be higher than the indicated airspeed due to reduced air density. Pilots can use performance charts, flight computers, or onboard instruments to calculate or estimate the true airspeed based on the indicated airspeed and the altitude. Entering the true airspeed on a flight plan allows air traffic control and other relevant authorities to accurately assess the performance capabilities of the aircraft, facilitate efficient traffic management, and ensure proper separation between aircraft. It's important to note that the estimated ground speed, GS, and indicated airspeed, IS, are also valuable pieces of information, but they serve different purposes and are not specifically required to be entered on the flight plan at the planned cruise altitude. Estimated ground speed represents the speed of the aircraft relative to the ground and is influenced by both the true airspeed and the effects of wind. Indicated airspeed, on the other hand, is the speed displayed on the aircraft's airspeed indicator and is used for reference during various flight phases. Therefore, on a flight plan, the type of speed that should be entered at the planned cruise altitude is the true airspeed.